So, oh, sorry, question. I don't see the online participants, so I think Maria.
You can put that on here now. When I take my
You
away.
can see, yeah.
No, we put them on. We just put
Yeah,
the computer
okay.
back up here. One moment.
Okay. So here, yeah.
Oops. Did something just fall out? Okay.
Yeah.
Yeah.
Thank you so much for this very interesting overview of causation. I have a, one is more like curiosity, and then I have a specific question. Curiosity is, I was surprised not to see Kant included, and I wondered why.
Okay.
Okay, and this is just a curiosity matter. And the other thing is, this is specific to the NES account.
Mm-hmm.
Do you think that this is what this account could be useful to capture the very way neuroscientists think about perturbations?
Yeah.
Because I think that this is a very important point in terms of like conceiving perturbations, not as causes, but as causal factors.
Mm-hmm.
So, and whether you think that this way of conceiving perturbations answers the confounder problem that was introduced by Conrad Coding before.
Exactly. So I wanted to, a very good question. I want to answer it. So Kant is just not a major figure in the theory of causation. So he had, it isn't here. He's just not a major figure. That's number one. As with regard to Ness and Einer's conditions, yes. Is there a pen that I can scribble on the board with?
Yep. Here. Here's the board.
So yeah. So the answer is yes and no. There is a literature on this, and it shows that the Ness condition cannot handle certain aspects of them, of the problems of overdetermination, but it can handle some. Okay, so it is exactly that, and I think that's what Conrad Conrad has done in his papers as well. So we just consider the case that we have three causal events: C1, C2, C3, and it's just the set of events that such that if they are on, off. So we just actually call it plus minus to make it easier. Plus minus, plus minus, plus minus. Such that if two of three are plus, then we have E. Okay? And otherwise we have not E. Simple as that. And then what we can do is we can look at all possible combinations of them. So we can have plus plus plus, plus plus minus, plus minus plus, and so on and so forth. And we can say, well, look, here we have a case of overdetermination, and what we'll do is we'll just break it down into those sets which are sufficient. So there's C1 plus C2 plus. That's sufficient, and both are necessary. So we can identify and we can break it down. It nests the counterfactuality. Okay, and then we can go through the whole story like that. So yes, that's exactly what you can do when the complexity gets large. You want to start breaking down the group of, let us say, events which are related by observation to a brain state being on and off. We want to actually break them down into sufficient conditions. Now we can do it further, but we could say, well, it works that way. Or we could do something else. We could again say, well, there's these neurological, it's firing. So if there's neuron 1 fires first, neuron 2 fires second and third. Now, we'll end up with different models of doing that, but it's basically the same thing. And that's so this Ness condition allows you to switch on and off the different neurons or areas of the brain in order to capture whether or not they are, in the language is better used, causal factors rather than the cause.
Yeah, follow up.
I completely understand the logic. What if you do not have access to all the seas? So
Right.
suppose that you have limited visibility to
Mhm.
the seas. This was the case that was
Yeah.
discussed before, where you have like 10
Yeah.
to 11 neurons. You do not have access to all the seas.
Right.
Is this still true?
So in theory, you can do it. What you do is that you may want to say is, look, that is embedded in a causal field. Imagine all these other C's are on, okay? Or all the other C's are off. And what do we observe when they are all on? A certain behavior or when they're all off. So what we can do is simply introduce this notion, say, okay, background conditions. And you can then, the more empirics that you do, and the more you can capture the C1, C2s and so on, you may be able to isolate then those factors. So there's nothing in the structure that prevents that being done, but it is a complicated problem because you have to make those underlying assumptions about what constitutes a causal field. What are the background conditions? But that's a process that we do anyway in any kind of analysis. What we do is we reduce something to its essential features on the basis of the experience that we have, that is to say, the empirics. And then we hypothesize and we sort of say, okay, that's the causal field, those are background conditions. And then we might find it doesn't work. We have to take something out of the causal field and so on. So the notion of a causal field is very, very unclear, by the way. I really don't want to be careful on this. So Mackie introduces it, and there's a couple of papers that deal with it. And many people say the Einus conditions are applicable, in this case, applicable to particular or singular causation in the law, but not so easily here, because in the law you can easily isolate the background conditions, but here you may not be able to. But in principle, it's possible.
More? Anything? Okay, then good.